Okay, so today we are going to be diving into topic 6, which is more on central tendency. So we're going to be looking at some of the more exotic forms of central tendency. But before we do, we should take a moment and recall the less exotic forms, the ones that you know pretty well, the ones we talked about last time. So what were those 3 ones we talked about last time? I think I heard someone say something. Mean, median, mode. Which we got? 3. Absolutely. Mean, median, and mode. And what is the distinction, Marie, between the mean, the median, and the mode?
The mean is like the average.
Uh-huh.
The median is the middle value. The mode is the most common number.
Exactly. So, when would you use the median over the mode, or vice versa?
If there's outliers, you wouldn't use the mean, or use the median better, right? The mean is for like the big picture.
Yeah.
Okay, yeah.
So resist the temptation to think that the existence of outliers determines which one you should use. Outliers are information. Outliers are part of the data. Like, there are people who make a lot of money. There are people who are really tall. Which one you use is dependent on what you're trying to learn from the data set. If you are trying to get a big picture of the data set, then you want to use the average because the outliers are going to be informative on that. Arguably, a problem with the median is it treats very large numbers the same as kind of large numbers, and very small numbers the same as kind of small numbers, right? It just tries to find the middle point. So, in some ways, the median is not very informative. You know, we talk about how the median cigarette smoked in the United States is probably 0, but that doesn't mean literally no one smokes. There are some people who do. So the average is actually more informative. Trying to get that big picture, the average is very useful. But if you're trying to find like the typical response, if you're trying to find the typical value, the median is more informative. I encounter some random person. Are they likely to be smokers? Probably not. They're probably not a smoker. They probably smoke 0. Right. The median is more important there. So it really depends on what you want for the typical versus the big picture. The mode, though, is typically used for what kind of data? With the C, categorical data. So how I want to structure today is cover the 2 other kinds of averages. We'll talk about the geometric mean and the weighted average. And then I'll show you how to do all this stuff, mean, median, mode, as well as weighted average, as well as geometric mean. I'll show you how to do all that in Excel. Okay. Let's begin. Let's think a little bit more about this average. Let's imagine I had 2 people. One person is 60 inches tall, and the other person is 50 inches tall. What is the average height? 55. If I were to take the 60-inch tall person and stack them on top of the 50-inch tall person, how much total height am I looking at? 110. Absolutely. Now, imagine I didn't really know anything about these heights. I just know that based on 2 people, the average height is 55. If I assumed both of them were the average height of 55, and I stacked them on top of each other, what would be my total height? Would it be the same?
Yeah.
Yes. Right. What's 55 plus 55? 110. So one way to check to see if an average makes sense is if you say, well, imagine we didn't know the actual observations. If all observations were the average, then the aggregate or the big picture should be the same as what we actually know about the individual data. That's an important thing to keep in mind as we go through this example of growth rates. What is a growth rate? might have been counting growth rates before. If you can give me mathematically what it is. If you've had some economics before, certainly you should know what this is. I assume you know what it is. If you haven't had any economics before, a lot quiet. Yeah. What is your name again? Gabe. Denominator is time. Well, kind of. I mean, it's all time. So I think what you're thinking of is the denominator is the value before. So if we're trying to figure out the growth rate of, say, enrollment, our denominator would be the previous period, the total number of people who enrolled. What's in the numerator? Exactly. And then you multiply it by 100%. In other words, the growth rate looks at what portion of the value was before and how much was added on in the next unit, in the next period. So if we're looking at 100 and maybe it's a 6% growth, that means in the next period it's 106. Because 6% of 100 is 6, and 6 was added on. If it's -3, that means it's 97. Because 3% of 100 is what? 3, and since it was negative, it was subtracted off rather than added. And you can see that in the numbers. If you take 97 minus 100, that's -3. -3 divided by 100 is 0.03, and that would be 100%. That would be -3%. So we're good so far? More or less how it works. So let's imagine we have period 0, period 1, period 2. We start with $1,000, and we know there is a 9% growth rate in the first period, and then there is a 1% growth rate in the second. After the first period, how much do I have? Let's say this is some hypothetical bank account or something. Put $1,000 in, I get 9% interest. How much do I have at the end of the first period? 1,090. Right, because 9% of 1,000 is 90. 90 plus 1,000 is 1,090. How much do I have at the end of the second period? Well, what's 1% of 1,000?
So it would be 1,190 cents.
Exactly. So 1% of 1,000 is, of course, 10, but we also have the 90 that we earned as well. 1% of 90 is 0.9, so that's 10.9 plus 1,090 is 1,100.9. Now, my question for you, like, what the hell does this have to do with anything we're talking about? Well, what's the average growth rate? We have 9% and 1%. What's the average growth rate?
5%?
5, right? Most people say 5, right? 5%. Well, maybe it is, maybe it's not. We can check, just like we did over here. Let's imagine that both periods are 5%. Start with 1,000. Will we get 1,100.9 at the end? If we do, then we know that that's right. And if we don't, we know something's wrong. So, what is 5% of 1,000? Yep, so 50, and then you add on 1,000 to that, 1,050. What would be 5% growth after that? is all of this? I was doing it in my head earlier and I forgot.
1,182.50.
That sounds right. Yeah. Yeah, that's right. Huh. Do they match? No. This is a little high, which suggests that the actual average growth rate is not 5%. It's higher or lower than that. Should it be higher than that or lower than that? Lower. It should be lower than that. We actually have two different averages that you can use. One is called the mean, or the arithmetic mean, the one that you use to get that 5. Arithmetic, meaning arithmetic, you added the two values and then divided. Then the other one we're going to talk about today is the geometric mean. It's more complicated, it's one you probably haven't heard of before, but when dealing with growth rates, it will give you an accurate average. I'm going to use geometric mean. For growth rates. Try to come in on time. 10 minutes late, CJ. All right. In order to understand what goes on with geometric growth rates, it's important to, or it's valuable, I should say, to get a mathematical equation to figure out what's going on here. Like, could we generalize what's going on here in an equation? If you're nodding your head, yes. It has to be something. It's math. Well, let's start by taking what I did here and let's turn it into one string of numbers. So, like, how would you go from 1,000 to 1,100.9? Well, you would obviously start with 1,000. And then you'd multiply by something. What did I multiply 1,000 by to get this? Not 0.09. 1.09. Why 1.09, CJ?
Because it's 100,000 and increase that. So 1,097 is 1,000
Because if you just do only 0.09, you will get how much is added. Yeah. But we want not just how much is added, we want to know what we have now. So that 1 includes our starting value. Does anyone know, by the way, what, say, investors call that starting value? Because with a P, principal. So you add in that 1 to include your principal. And that theme is going to be really important later. So this value is this. What will we multiply this by to get this? 1.01. So we can just add that right here. And this equation turns this into this. Good? So let's generalize this a bit more. We're going to take our starting value, or principal, and we're going to multiply it not by a summation notation. We want to be able to do this for any number of periods, right? Each one of these is a period. We want to do this for any number of periods, n periods. Which means each one of these values, we are not adding them together. That's summation notation. We are multiplying them together. And does anyone know what the symbol is for multiplication notation? Coming in late. If I get here on time, please. I don't want to start bringing down the hammer. What do you call summation? What, anyone know what would be the multiplication notation? What it would look like? You know this as pi, but you really know this. This is pi. This is lowercase pi. This is 3.141592653.787. This is uppercase pi. This is our multiplication notation. In summation notation, you took the individual items and then you added them together. In multiplication notation, it's exactly the same thing, except now these individual items are going to be multiplied together, right? Like what we see here. I equals 1, all the way out to the nth period. And we have some parentheses. What did we do to these growth rates? We have x, but what did we do through the individual growth rate? Or the ith growth rate? But we didn't multiply the growth rates together. Right? We multiplied the growth rates plus something. What did we add to them? Principal. What? Principal. Right, for the principal, I mean, to include the principal. Oh, I should have really put in the starting value because that doesn't look like the next. So you take the starting value, and then you multiply it by this thing, and that gives you the value at nth period. Where x is always a decimal, x is always something that's less than, I mean, it doesn't have to be less than 1. It typically is less than 1. You can have like a 300% growth if you really want to. Doesn't happen very often, but it's possible. So that's more or less how we get from here to there. So you can, if we added a third option of a 3% growth rate, then we can easily put this in. Note too the advantage of using adding in that principal. How would we reflect a negative 3% growth rate? 0.97, right? And then you can immediately see the intuition there. If you have 1,000, then you take that times 0.97, now you have 970. Right? It's lower, as it should be. The growth rate was negative. Any questions on this? Now what I'm going to do is show you the geometric mean, and you should see some symmetry between how we calculate this, going from a starting value to the value of n, to how you calculate the geometric mean. Our geometric mean equals, we're going to have a really big value right here, really large root, and we're going to call this the nth root. And then we're basically going to do the same thing here. N I equals 1, 1 plus xi, and then you subtract 1 at the end. So note, this is exactly the same as this. But we want to find an average, so we're going to take this value and then we're going to take the nth root to essentially undo all the multiplication we did. Note that's kind of like, there's a little bit of symmetry between this and the arithmetic mean. And the arithmetic mean, you add it together. What's the opposite of add? Subtract. But kind of what's one step above subtract? Divide, right? And then you divide it by the number there. Here, you're multiplying. But what's one step above multiplying? Well, exponents, right? Taking it to the nth power. But what's the opposite of taking it to the nth power? Taking it to the nth root. So there's symmetry there. I appreciate that symmetry. Now, as far as Excel goes, as far as the standard definition of geometric mean, the 1 is not there. You just multiply the values together and then take the nth root. So in this case, the middle and the average, the geometric mean between 9 and 1 is 3, because 9 times 1 is 9. the square root of 9, because we have 2 observations, is 3. That's 3. That's the middle number there. But because we're doing explicitly with growth rates, I add 1 here for the principal, and then I subtract 1. Again, you really need that. Because if you had, like, say, if this was a 9 and negative 1, then you'll be taking 0.09 times negative 0.01 and then taking the square root of that. What's the problem with that? It's not a real number, right? You can't take the square root of a negative number. You have to throw in some imaginary. You don't want to. Doesn't make any sense. You should be able to come up with an average between 9% growth and negative 1% growth that isn't imaginary. Like there's no obvious. No, that's weird. But if you add 1, now you're going to be taking 1.09 times 0.99, 1 minus 0.01. And that obviously is going to be an average you can take, a square root you can take. Any questions so far? Yes, Joyce?
Will we need to know this for our exam?
I'm largely showing this part for you so you can appreciate where this is coming from. This, I believe, I put on a formula sheet on your exam. I'll have to check the practice and see if I do that, but I'm pretty sure I do. So, but have no fear, you won't have to calculate this by hand. I'll show you how to do this in Excel. So, I'm curious then, what is the geometric mean of 9% and 1%? Again, remember, if it's more accurate than the average, it's going to be lower. So, I'm going to erase this part here. So I have some place to work. What is, so we have this right here, 1.09 times 1.01. So I am, for every single value, I'm adding 1 to it. And then I'm multiplying them together, like we did right here. How many observations do I have? 2. And then I have to subtract 1 to undo the addition I did within the parentheses. Essentially account for it. And when you do that, you get 0.0492 or 4.29%. So, as predicted, slightly lower than this 5. If you take the arithmetic mean, you're going to overestimate. Try to come in on time. They're over 20 minutes late. There's a slight error in the notes, though I will fix that. It says 0.492 rather than 0.0492. So, my mistake on there, and I'll fix that as soon as I can. Or if I don't get around to it, just remember that's the notes. So, let's imagine we do 0.92% and 4.92%. This obviously becomes 1,049.2. Oops, sorry. No, that's right, that's right. And then for those of you who have a calculator, it won't be perfect because I had to round. But if you take 1,049.2 and you multiply it by 1.0492, does anyone know what you get? Good. It's not perfect because I had to round, but you get. And if we had the whole string of all the variables, it would be exactly the same. Yeah. Well, that's because you put the -1 inside the inside the square root, and then you put -1 outside the square root. You want to put the negative outside the square root. I'm sorry, the negative 1 outside the square root. Minus 1. Any questions about this? Again, I'll show you Excel. Excel's a lot faster anyway. All right. Let's go to this. And that's our geometric mean. Let's move over to a different kind of average. I'm sort of like weird about data. I really love data. And whenever I get my gas tank filled on my car, I check to see what my gas mileage is. I know that some cars will calculate that automatically. I don't trust those cars though, because they don't know how much gas is really going into the car. And I'm not entirely sure that they know how much gas they're using at the time. So you can do this yourself. Whenever you fill up your gas tank, reset the trip on the odometer. And then next time you go fill up your gas tank, record how many miles you went on your odometer and how many gallons you used to fill up your tank. Right? Because you can see that on the gas tank. That's how many gallons you use. And then you will know what your gas mileage is. And you just do that every time you fill up your tank. And then you reset your odometer again, and then drive around, and when you fill it up again, you make a note. It's really great. Every time I do it, every time I fill it up, I have all this great data. It's really great. You can see too how like your gas mileage goes up and down based on the weather. And I get irritated when my wife fills up my gas tank for the car because she doesn't do that. It throws off my data. But there's also like I have a hybrid. We have a hybrid, and it shows us what the gas mileage is, and it's wrong. It's like always wrong. It's like always overstating about it too much. It just drives me crazy. So with that in mind, I want to show you some hypothetical data. This is miles per gallon. Here is miles on that particular trip. Here is gallons. And so this is going to be, I tell you that it's hybrid because you're going to see some very high numbers for miles per gallon, and I want you to know why. Let's suppose, what were the numbers I was using? Oh yeah. Let's imagine that I'm driving my car around, and we're going to go on a trip soon. So even though it's nowhere near empty, I'm going to just top it off. And then we take our trip, and we drive for 400 miles, and then I refill the gas tank, and I got 8. Now, for the first one, what was my miles per gallon? 100. You took 50 divided by 0.5. Second trip, what was my miles per gallon? 50, exactly, 400 divided by 8. So, on average, how well does this car do on miles per gallon? 75. How'd you get 75, Michael? What? Oh, yeah, that's easy, right? Yeah. Does everyone agree with the result is? Yeah, CJ? Wait. So, you got 75, you got 450, because, I'm sorry, no, you got about 52, I said, and doing this. So, who's right? We're saying CJ is right. Why?
Because, to me, it's like kind of like a weighted average, because you have 8 gallons at 50 miles a gallon, you only have half a gallon at 100 miles a gallon, so you have to account for that somehow.
Yeah.
And it's kind of like when you take the average, you can't take averages of averages. The average kind of takes away how many subjects, like it's taking the average up.
Mm-hmm.
So if you take an average of those 2 averages, you use 8 gallons.
Yeah.
It's a half a gallon.
Exactly. Right? It seems right, like your instinct is good, but admit it's kind of strange because when you take the average in the way that you did, without, and you use the magic word for weighted average, without putting more importance on one or the other, you're sort of treating these equally. But clearly, this is going to tell you more than this one. This one's only based on half a gallon. Right? This one's based on a larger hunk of the total gallons you've used. So this should have more weight. It should have more importance. Right? And that's what we call a weighted average. So weighted average is actually composed of two summation notations. On our numerator, I want to make this a little bigger right here. Equals 1 all the way up to n. You have individual weights, or how important each observation is to the overall average, and then individual values. Those values of those observations. The W is weight, and then that's a value. And note, both of these have the subscript I, because the first observation will have a weight attached to it. The second observation will have a different weight, possibly a different weight attached to it, and so forth. We then divide by the sum of all the weights. Typically, weights are done as percents. So typically, the sum of all the weights is 1. It doesn't have to be, as we'll find out, but typically it is. This is a lot of how your grades are calculated. So I assume that for all of your classes, you guess things like exams are 50% of the grade, and homework is 10%, and a paper is 40%. Maybe not exactly this distribution, but something like it. I'm going to say paper is because that's a really important paper. It's 20% of your grade. Does that look familiar? That general, most people structure it this way. So if you got a 90 on the exams and 100 on the paper, you just sort of 100 on the homework, and you sort of slacked off, and maybe you got like 70 on your papers. What is your grade for the class? What is your weighted average? By the way, this is how I calculate your grade too.
83%.
So how'd you get 83%?
50. So you get 45. Oh, so 50% of 90, so you get 45 points on that.
So note what he's doing is he's taking the weight, which is 0.5 or 50%, and multiplying it by the value, which is 90.
45 from that. Do the same thing. You get 10 from that.
Yeah.
And then you get 20 from that.
0.4 times 70 is 28, and then you add them up, and you get 83. Now, technically, what you're also doing is you're dividing by the sum of all the weights. But what's the sum of all the weights here? 100. In decimal form, it's 1. So 83 divided by 1, 1. So you're done. If you note that everything adds up to 100%, then you don't really need to do anything else. What if and I get this happening a lot. What if you don't know your exam yet? What if this is like the final exam, and this is what's been happening so far in the class, and you want to know, how am I doing so far in the class? And the physicist says, oh, okay, well, 10% of 100 is 10, and 40% of 70 is 28, so you're getting a 38. Yeah, you're failing. Are you failing? Yeah, it's only out of 50, right? So since we don't have all the information, we don't have this right here, what do I divide this by? What's the sum of 0.5, right? You divide by the sum of all the weights. $38 divided by 0.5, you can do that in your head. 76. Good news is you're not failing. But you need to do really well in this exam. So, I just showed you how to calculate your grade to date. This is what I do whenever anyone comes to my office and they say, how am I doing in this class? What's my grade to date? I do this exercise. I should not see any of my stat students coming to my office now asking their grade to date. You can figure it out. Just do the math. Right? You have all your data. Typically, the only X factor is your participation, but generally people can estimate that. It's a small part of the grade anyway, relatively speaking. Just figure it out. You don't need to keep asking me. This is also, by the way, how I calculate your midterms, too. I only have half that information, not even half the information because you have papers due at the end. So, yeah, you have a question? No? Okay. Any questions on this? Let's then dive into Excel. So what we're going to show you how to do is how to do mean, median, mode in Excel. We're also going to show you how to do geometric mean in Excel, and we'll show you how to do weighted average in Excel. It'll be lots of fun. So, let me get rid of my. As normal, I asked you to go to my website. Today we're going to be working with dataset 2. Dataset 2. So if you go to my website, go to BSA, teaching section, then you go to BSAD 210. You'll see, of course, this, and you'll see dataset 2. This should give you data on Disney sales. So of course, the very first thing you should do is you should get rid of that. You should select that enable editing so you can manipulate this. Otherwise, it'll get really pissed at you. No, it's like, oh no. In my container, it doesn't contain harvesting. Somebody in from our website. Does everyone have this ready to go? Okay, let's zoom in. Yeah. Okay. So, what this data comprises of, we have year right here on our column A, from 97 to, how does it go up to? 2014. And then I've broken down Disney sales on the far right. You have the total Disney sales for the whole company, and then there's the components of the company, so the studio, the consumer products, the parks and resorts. And then in the B and C columns, we have that year, which section had the most growth from the previous years. Interactive did the best that year. Parks did the best in '99. Studio did the best in 2001. Interactive again in 2000. If you want to know which section most often got number one for the growth, how would you figure that out? What tool in your toolbox would you use? Mode, because this is a categorical data. One category, the studio, one category, that's consumer products. I number them 1, 2, etc. So if you want, you can pop over right here to C4, which we have some empty space we can work with right here. We're going to select. How do we figure out mode? It's been a while. How would you figure out the mode of this data? Rolando, if you don't know how to do something in Excel, and you want to get to do something for you, what do you type? Equals. The secret is equals, and then start typing basically what you want. Sounds like we want mode. Let's do mode. Now, my notes are based off of a slightly older version of Excel. Most of the time I've updated them. For this one I missed, I didn't update it. I have in my notes just mode. You can see it's mode with the little like warning symbol by it. What is, I don't really know, it's like an alert symbol really. It's not a warning, it's an alert. It's just letting you know that this function is for an older version. It still works, you can still use it. But Excel has updated to give you actually two different versions of mode. The mode single will give you one single value. It's literally the same thing as this one, as the old version. This one is multiple, which honestly I haven't played with. It apparently gives a vertical array, so I guess an account for multiple modes. You can play with that if you want, but I haven't played with it yet. Let's focus on mode single. Or if you want to do just mode, you can do that as well. Both of those work. So select that one and I press tab.
Press what?
Tab. So once you select something, it'll then capitalize everything, and it'll then have your opening parentheses, and you can start typing. What should I do next? Highlight. So let's highlight from C5 all the way down to C21. And close. You highlighted B. I haven't highlighted B. What happens? I don't think it'll work if you highlight it. No, well, I did it for regular mode. Just did outside. Yeah. That's why I had to add numbers here. I had to put them. Interactive is 5, Parks is 3, because if you try to highlight the name, it won't. It'll treat it as a string, not as a value, or what it'll do with it. Which is kind of dumb, but you know, still isn't perfect. And then if you hit enter, what do you get? 3. So what does that mean? Parks 3. Parks most often in any given year have the most growth. Now, granted, that doesn't mean that Parks is most often the number, is like this really great opportunity. We don't know, for example, who has the least growth every year. We had a different column of least growth. For all we know, Parks could be in that one too. Maybe it's a very volatile section. We don't know, but we at least know that it most often has the number 1 growth. That's pretty nice. That's pretty nice to know. Well, I also am curious about median sales and mean sales. I don't mean mean as in like not nice. I mean as much mean as ever. So I'm going to put median right here on B23. I'm going to label it B23 for medium, and then I'll put it in D23 here, and then mean will be B24 right here. So if I want to get the median, how do I figure that out? Median? Did you say something? Equals median. And we highlight. And by the way, if you don't want to highlight, you can just type in D4 colon D21. Oh, let me scroll that up again so you can see. D4 D21 gives you the median. $69.50. Of course, this is in millions too, so this is about 6.9 billion. What about the average? Mean. Yeah. So yeah, you don't type in equals mean, because if you type in equals mean, Excel doesn't know that. Excel recognizes that most people don't know mean as average. They know it as average. So you type in average. And again, you can type in, if you want, you can do D3 D4, D21. If you get tired of highlighting things, you can always just type it if you know where you're going, because you don't have to scroll up and down. It saves you a little bit of time. Yeah?
What do you press to see the rating?
So remember what you press? Control, tilde. Yeah. So the little number next to the 1. What's your name again? Gabe. I already asked that, didn't I? Yeah, I did. Sorry, Gabe. Does anyone have any questions on this? Note, in this case, the median and the median are actually pretty close. So that's kind of nice. Pretty close. They're very close, actually. Well, less than 20 away. Now, I don't want this, though, just for what was this? It was Studio. I want it for all of them. So how do I get it for all of them? No, I just want to do the same thing, but for the other section. So okay, yeah, we could highlight these and we can drag it across. There's a little problem though when you do that. What is the problem when you do that? Yeah. It's taking the average of this crap. You don't want to do that, right? Because we talked about how you don't want to take the average. You want to take the average of percents of growth rates using the geometric mean. You don't want to use the arithmetic mean. And granted, like, you know, if you turn this into percent, then you can see it. But again, you don't want that information. You want to leave that blank. So how can I do it? How can I get it for each individual category, leaving a blank column between each one?
Copy and paste.
Ike, what'd you say?
Copy and paste the formula.
Oh, God, so you want me to copy here, and then paste, select and paste here, and then select and paste here, and then select. Are you kidding me?
Go to the top and do something.
When we dragged over, so I mean, you can do it Ike's way, and that's fine, but that can get a little time consuming, especially with a lot of categories. Dragging is so much faster, but dragging, of course, uses stuff we don't want to use. When we dragged to copy and paste, how did it know what to paste? Like, and this is not meant to be a trick question. When I did this, how did it know it wanted this right here? And not like say this right here. What did it reference? I can't remember your name.
Christian.
Christian. What did it reference?
We use the dollar sign before the 4 and the 21.
So you said between the 4 and the 21?
Yes.
I mean, it is copy and paste that. It's updating it. But how does it know which cells to copy and paste? Because it didn't do anything in row 25. It didn't drag 25 over. Why did it only drag these two? Because that's the one that I highlighted. You see where I'm going with this? Anyone? Don't highlight these two, highlight these 4. And then when you copy and paste it, it will copy and paste the blanks in E, and it will skip every other column for you. Isn't that cool? Right? You set the standard, and then you tell it to do it, and it's like, okay, fine. Now we got the blanks in every other column. So I didn't highlight just the 2 numbers. I highlighted the 2 numbers and the 2 cells next to them. And that's what I've selected as my standard for what this is the template you will be copying and pasting, therefore leaving every other column blank.
I don't do that so much fun. I feel like if you're so like clever, like, that's fine, you just try to copy something.
Grab it a one. Any questions? Okay, so that's just mean, median, mode. That's pretty straightforward. But, you know, I do sort of want to know what the average growth rate is. I do want to know that. I can't use the arithmetic mean. We've discovered that's inaccurate. So what do I do instead? Well, I'm going to have to follow my geometric mean. Let's write it actually right here. So the geometric mean equals to the nth root of the product of 1 plus x minus 1. That's a geometric mean. What's the order of operations? Remember your order of operations from math? What is the order of operations? I don't want to call this one. I said I want to call someone. That would be fun. We'll take that one. Is Austin here? Let's wait a minute, okay, Austin, what's your order of operations? What's the very first thing you do? No. Before that. Before that. David, what else? Parentheses, right? Parentheses are our first thing. So when we take a look at that equation all the way on the left, what's the very first thing you see? The 1 plus x. So the very first thing we have to do is do the 1 plus x. What does that 1 plus x represent? I'm asking, what does the 1 plus x represent? No, x is the growth rate. So in other words, we take every observation, because it's xi, so it's going to be n observation, all the way from x1 to xn. And then we add 1 to every observation. So there's 2 ways to do this in Excel. I'm going to show you the slow, kind of clunky way, but it has the advantage of showing you every step in this, and then I'll show you the faster way. So here's the slow, clunky way. The first thing because the very first thing we do is we have to add 1 to every observation, we're going to need a new column. So if you right-click F and insert, you got a new column here. And we have a just going to equals 1 plus E5. 1 plus E5. And that'll be our first step. And then once you hit enter, you can double click that box in the lower right hand corner. Right here, and it'll bring it all the way down, and you'll now have an array of 1 plus x rather than just x. It's going to be percent. You can remove the percent if you want, or you can just ignore it. It doesn't really matter. This is just an intermediary step to what you ultimately want. I'm going to put this in F24 because I had selected 24 as where I'm going to put the mean, 24 is where I'm putting the mean. The next step is everyone here? Does everyone have this?
Can you click on the box for value 1 so I can see the...
In this right here? Even if you do, E21 plus 1, obviously it doesn't matter. Does everyone have this row stuff with the step? Now we get to do the fun part. So, again, this plus 1, minus 1 thing I do is the extra step that I put in. that makes it basically easy and possible to calculate these growth rates in this intuitive way. But this part, the multiplication part and the nth root part, is all stuff that Excel will do for you. And that is done with the function. What do you suppose we call that function? Yeah, equals geomean. There it is. And we're just going to highlight everything we covered. It'll start, of course, at F5 because we don't have a growth rate for F4, since we don't have anything to compare to. What that part represents is this right here. Doesn't include the -1, only this right here. We made this part, then we're telling it to multiply all these sections together and taking the nth root. And so the very last thing we have to do is subtract 1. Now, if it's saying 0, it's because you need some decimal places. It turns out to be a pretty small number. Minus a 0 as well. Let's turn it into a, for 1, it's saying it's a number. We want it as a percent. 2, it's saying 0%. That's because it's small. So add some decimal places. Yeah. It's sad growth. Look at that. It's like really sad. Granted, I guess like a quarter of a point of growth over 14 years can add up to a lot. But like when we look at the numbers, it started out as like 6,900, almost 7,000, and then it's like 72, almost 7,300. I mean, I guess if we're talking in like the millions of dollars, that ends up being a lot, but not super stuff. A lot. Look at all the growth that happened. What the hell was that? What? In 2014 for the studio? What did they release in 2014? I'm trying to think. Because they had a lot of growth. 21.7. You can see this is really volatile too. Sometimes the movie is good, sometimes the movie is
Was that
not.
Star Wars? No.
No, that's 20. No, I'm talking 2014. Someone will look it up and then we'll know. But okay, so that you can see every step that we do, right? But that's annoying. Why is this an annoying way to do it? Why is this annoying? Yeah, I gotta make all the column, and we can't, because we have to make a column, we can't copy and paste it. Damn it! So let's do something else. This is another way. Excel is this wonderful program, but there's a lot in it, and you don't always know everything in it. And so I was irritated I had to do it this way, and then a student showed me how to do it another way. I got really excited, so I'm going to show you that too. For one, what we would like to do is do the geomean, and then within the geomean section, add 1, and then after the geomean parentheses, subtract 1. So we can include it all in one command. That's what we would like to do, because then we can copy and paste it, and not have to make a whole new column. The problem is if you try to do that, you do geomean, and then you highlight, and then you say, oh, I'm going to add 1, then end the parentheses and subtract 1. So if you try to do it this way and you hit enter, Excel is going to get all pissed at you. What are you doing? You can't do that. All right, fine. For some reason, and I'm not exactly sure why this works, but for some reason, if you open this with a command called SUMPRODUCT, something we'll be talking about in a moment, and then you close the parentheses, then it works. It gives you way too many decimal places. I think that's just because of you can see these numbers were actually calculated, so it's giving you like the pure number rather than a rounded one. Don't worry, I'll show this whole thing in a minute. I just want to round it off. There we go. If you put this in, you can condense it now, for some whatever reason, reads this as a valid equation. I wish I knew why this worked, but it does. And at some level, that's kind of all you care about. This is much faster. You have to create a whole new column, and now we can copy and paste this if we want, and find out all the other ones. I don't care which one you use for an exam. This one is faster, but the other one is kind of easier to remember because you explicitly do all the steps. And like the use of sum product is so random, it's easy to forget that's what you have to include. I don't care which one you use, but I wanted to show you both because the first one is more instructive and the second one is faster. Any questions? No? 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 Great. No, of course, we come up with the same number. Right. Last bit, let's talk weighted average. And you can do that weighted average if you go to performance review, because they don't have a good weighted average example. But that's because I got growth rates over time. I want to do something a little different. So here we have Andy's performance review. Or Andy. Andy is really great at sales. But I guess everyone gets really pissed at him. Maybe he's kind of rude. Or maybe he's just like really manipulative. I don't know. But he shows up a lot. What does Andy get for his performance review? So I'm going to show you the fast way to do this and the slow way to do this. Let's start with the slow way, because again, like before, it's more instructive. When we do weighted average, what do we multiply what by? Weight times value, absolutely, of course. So we're going to do that here. Weight times value, in this case, the score. B3 times C3. And we don't want to do it once. We want to do it with every one of these, right? So copy and paste. So these individual steps of multiplication is this part right here. Then what's our next step? You don't say it, or call where's Renew? Renew here? Oh, Renew. What's our next step? Well, we don't need to divide anything yet. We're not there yet.
Oh, sum.
Sum. Yeah, we got to add all these components together. Yes, 87. Now, do we need to now divide by 3? Because we have 3 different things here. Do we need to divide by 3? No. No, don't do that. People love doing that. It drives me crazy. Don't do that. Do we need to divide by anything?
No.
No. Technically we do, but technically we don't. Right? Technically we do because we have this sum of all the weights here. But technically we don't because what is the sum of all the weights? 1. 1. Right? 10% plus 90% plus 60% plus 100% or 1. So we are done. But like before, that's annoying. Any questions on this? Like before, that's a little annoying because we have to make a whole new column. Luckily, our friend sum product can do it for us. Oops, not sum product. Sum products has multiple arrays as inputs. So you will put in this case, 2 arrays, one of all the weights and one of all the values or the scores. And then the Excel will take the first value of the weight, pair it with the first value of the score, multiply it together. Do that with the second one, the third one, the fourth one, and then have a whole bunch of products, a whole bunch of multiplied values, and then it will add them together. So it'll do all the multiplication and then do all the addition in one step. How's highlight all the weights, comma, highlight all the scores. You can close your parentheses, or you can just hit enter. 87. Again, each one of these is valid. This is the more detailed one, so you can see the steps. This one is, of course, faster. Any questions? No? Awesome. We're blazing through. Okay, well, let's suppose poor Andy doesn't yet know his sales data yet. So delete that 100. Doesn't know his sales data. And he wants to know how is he doing. Well, does that mean he's getting a 27? No. What does it mean? What is his actual performance review? What should it be? What was your name again? Patrick. What did you say? 27 divided by 40. So that would mean 0.4. Did you say 0.4? Yes. Because you want to add it by the weights, right? And the weights, these are actually decimals. If you do by 0.4, you'll get something 100 times smaller than what you want. Divided by 40, you'll get something that's way less than 1. It'll be worse. You can think of it as a percentage. Then you multiply it by 100. Okay. So, 27 divided by 0.4. You're not doing that great, Patrick. I'm sorry, not Patrick. Adam. Andy, that's his name. You're not doing that great, Andy. 67.5.
What was the formula for that?
So I just summed the weights that I knew. And the weights I know are the first two. Because these are the ones we have scores for. So that's just 0.1 plus 0.3 is 0.4. Right. Again, I'm just following this equation right here, the sum of all the weights. Any questions? Yeah, oh yeah, I could do that all in one step if I wanted, absolutely. Yeah, I could if you want, I can. Let's delete that. I could do this, divided by 0.4. Just 0.5. Name is? Rogan. I ask that every day, I'm so sorry. Okay, Rogan, what's up? So I knew it was 0.4 because I have information on attendance. I have information on customer reviews. I do not have information on sales. So if you take the two that I do have information for and add them together, that's 0.4. Right? Because this is the weight 1 plus weight 2, 0.1 plus 0.3, 0.4. Any other questions? Okay. Well, we got 5 minutes left. Let's see if we can answer the question that goes this section with. We have miles per gallon, miles, and gallons. Miles is 50 and 400. Gallons is 0.5 and 8. And how do you calculate miles per gallon? Anyone? How do you calculate miles per gallon? Excellent. So in this case, B2 divided by C2. Now, we're going to sum that one up. We're going to sum that one up. And as noted, we can get a nice. There's that. So my question for you, how would we do a weighted average here so that if we took the 100 as inputs and the 50 as inputs, we would get 52.94? How would we do that? Adam? Now, why do we make the weight the
gallons and not the miles the weight? Why is the weight not the miles?
I can't even really tell you, I just,
Because the gallons is in the denominator, essentially.
So if you try to do it as the weight being the miles, you're going to get a totally different answer.
What percent of the gallons were done under the first observation, or the first with the 100 miles? What percent? How do we figure that out? Exactly. Divided by 8.5. Then we can, of course, make that F4 to lock it,
So that when we drag it down to the next one, we can do the other one. In other words, a little more than 5%, almost 6% of all the miles done were on the 100, and then 94% were done on the other one. So naturally, this one should have a lot more weight than the other one. And then you do a sum product. First array over here, second array over here, 52.94. Yeah,
What's the equation for 52.94?
I'll show you all the equations. Let me shrink D a little bit so that I'm not going to need the number. That's what I did. Another thing you could do, if you were so inclined, is you could take the gallons, multiply by this MPG, take the gallons here, multiply by that MPG, and then divide by the total weights. Treat the gallons itself as the weight, and then divide by the total weights, and you will get the same result. And appreciate why that works. It's B2 divided by C2 times C2 plus, need a space here, B3 divided by C3 times C3 divided by C2 plus C3. And what is that the same thing as? Cancels, 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 cancels. B2 plus B3 divided by C2 plus C3, which is exactly what we did to get that first time one over there when CJ did it. So that's why, that's a more detailed reason for why we have to use gallons and not miles, because we have to be able to do this. You know, there's a mathematical similarity now in what we're doing. Any questions? One very last thing I wanted to show you before I let you go. This will be really fast. Let's go back to Disney sales. And let's suppose as you're scrolling, you're looking at these different values. Oops. Oh, I copied it over. Okay, well, I guess I'll do that now. And you want to know, I have all this information, but as I'm scrolling, I have no idea what's what. I have no idea what's what. Is this interactive? Is this? It would be nice if we could take that top row, the top section, with all the information on it and freeze it so that as we scroll down, we can still see it. Does anyone know how to do that? Exactly. And the best option, honestly, is to select the upper left-hand corner of the thing you do not want frozen. So I want everything above B4 to be frozen, and I want everything to the left of B4 to be frozen. And then under View, under Freeze Panes, select Freeze Panes. And you see the little icon. This is the thing that you have. The blue is what you have selected, and then the stuff up and to the left of it are things that are frozen. And now when I scroll down, all of those things are the same, and I can see studio growth, and also I can see the year too. Look at that. The year is exactly where it's frozen as well, so I can reference the year very easily. I did this. I selected B4, just select it, and then I went to Freeze Panes. And you'll see this first. If this says unfreeze panes, unfreeze it, and then select that first option for freeze panes. I never use the freeze top row, freeze first column. They're too limiting for me. I like to be able to customize exactly what I'm freezing, and freeze panes lets you do that first option. So that often when you work in Excel, you work with a lot of data, with a lot of observations, with maybe a lot of stuff going down, so you'll lose the top row with the titles, or a lot of stuff going to the right, which means you'll lose the first column and the first few columns with information you need. So being able to freeze that so you always see that information is useful. I didn't do that at the very beginning though, because one of the disadvantages is it takes up space. It takes up actual space. You know, as you can see, I don't have a lot more data here, and I lose half of it in the titles. So. All right, with that in mind, I gotta let you go. If there are no more questions, no? Great. I will see you on Tuesday. Have a great weekend, everyone.